He was just here. Good morning. Good morning. Bom dia. There's going to be some demonstrations scheduled in the morning coffee break this morning in the demo area, so check the online schedule. We also appreciate your feedback on all these sessions. Just go to the TNC website and just click on the top right on the feedback. And also note there's no lunch today. Only the afternoon meeting participants have lunch provided. And as others have been mentioning, the Presidential Car Museum's on the first floor if you're interested in checking that out. We're just going to be starting in just a moment here. Thank you very much for joining the network session, Network-Centric Services. Roger Spoor, Roland, and Domenico are going to have some really interesting presentations, and I think we all appreciate everyone coming to the Thursday slot after the gala. It's always a tough slot to be in, and I'd like to hand over to Roger, and thanks very much, Roger, and take it away.
Okay, morning everybody. So, my presentation is about our project EduVPN. It's kind of in a proof of concept state, but it's already running, and I would like to challenge you guys just use our test EduVPN setup. I'm not sure if everybody is aware about the security issues related to going online on public Wi-Fi. So for the people interested, I have just started a rogue access point, tnc15. So tnc15 free Wi-Fi. It will be routed via my Nexus 7 with some nice stuff working on it. It will do SSL stripping. So you will for sure get some pop-ups normally. Well, some devices won't give you pop-ups, so then you really have a problem. And then after the session, we can just check what my rogue access point has gathered from your device. So in normal life, we are used to that when we are, well, walking around or doing whatever we like, we sometimes meet signs like this. Warning. But the strange thing, when you go online via public hotspots, and nobody is really aware that it's kind of dangerous. So this is really strange. So the world is an unsafe place. At least free Wi-Fi or public Wi-Fi environments like those hotspots you have, the captive portal stuff. So 2 days ago, in the news, I read this page from Ars Technica. It was about that if you have a Samsung phone, there's an issue with the keyboard, and somehow the keyboard is going to a website because of, I think, some language stuff it's trying to get, and there is a security issue, and an attacker can easily take over your device. So if you go online in places like this via tnc15 with the password, I can easily, with my rogue access point, beat the same SSID, go in between and compromise your device. And because this is relatively easy to do, anybody could do such a thing on the airport, etc. We decided we should come up with some kind of a protection for our end users. We must somehow try to protect them and make the world a safer place. EduVPN. Just some marketing, you won't forget. So we thought, well, how can we make sure our users will use EduVPN? And what is challenging, I think, is that when you inform users, when I should tell my wife, use a VPN when you go online on the airport or online in a pub or whatever, yeah, I'm pretty much sure that won't work. My wife will forget. Or she will be in a hurry and wants to check something. She doesn't have internet in another country. She will just go online via public hotspot. So that's why we thought it must be we must have something that's just working always. So you should have VPN turned on always. Not in unsafe places, just always. And as a service, it should be so easy to configure, easy to run as a normal user, that it's kind of plug and play. That's what we were aiming for. So at the beginning, we were checking what kind of underlying VPN technique we are going to use. There are, well, we considered actually 3. The upper one is Soft Eater. This is like a golden hammer. It supports everything. This is really a great product. Really great. Many protocols. It can do a DNS, tunneling over a DNS. So in some airports, or so in some planes even, where you have to pay for internet, you can use their tunneling technique, and you have free internet in the plane. You don't need even to pay. But the thing is, because of the enormous amount of features in the product, and we had a look on how it was structured, the code, we thought this really is a security risk. It is, well, it's too big as a VPN product. We thought it was a security risk to start using this VPN. We also considered L2TP. Nice thing about L2TP is that it integrates very good with Android iOS on a lower level in the kernel. But by default, you don't have encryption, so you should do IPsec as well. And last option, that's actually what we were using right now, it's OpenVPN. The disadvantage about OpenVPN is that it's not integrated on the lower levels, on the root level. But the nice thing is that you have clients for all kinds of devices, and it just works. And also, it was audited and hardened by the Dutch government. They made a separate branch, so called OpenVPN NL. But they also patched the open source versions. When we start deploying it, we hired a guy to do some auditing, just to be sure that we were using the right ciphers. And as you might know, I think since last year or 1.5 years, it's very challenging to do SSL, TLS settings on the right level on your web page. Many organizations, many institutes, universities, they just don't do it right. They use wrong ciphers, like having SSL v3 still enabled. That's challenging, and we actually have the same issues with running a VPN server. You should be aware, check your ciphers, check your configurations, and it is kind of quite hard to do it right. Even we hired an external guy, he did some auditing, he advised us, and recently we discovered it was still not on the best hardened level. So we'll change that soon. So, and everything we have done is put on GitHub, even our configuration, so it's for everybody quite easy to deploy a comparable setup as we have. So we think it's tricky to configure OpenVPN, but currently the best product to go for. So what is our design? So we support, or well, support, we are using OpenVPN clients that already somebody has wrote for all kinds of devices like Android, iOS, Windows, macOS, etc. And we have created an enrollment via our federation infrastructure. So a user just logs in via their own identity provider of their own university, then comes on our EduVPN servers. Then you can just create your configuration, and configuration, there will be a certificate per device. And when you incorporate or download the configuration into your device, you can just start the VPN to our server. And all traffic, there will be a default route going via our server. And because of privacy, we currently, on our server, don't know which users are using the service. Obviously, via our federation, we could, if there's any abuse, we could find out who is. But currently, on the server, we don't gather any email addresses or so from our users. So this is our basic concept, and I will just show you how it works. And because I couldn't put my laptop here, I have just made some slides how the process works if you go and log in. And you guys, you can do it yourself. Just go to eduvpn.servcloud.nl. This is the first stage, the first screen you will see. It's our federation, where are you from screen. You guys, most of guys are not joined by our federation, so you can just use the OneGenie IDP. Via OneGenie, you can just log in via Facebook, Google, or create a new account if you like, a OneGenie account. And after that, this is our service. And this website really looks basic. Why is this website showing so basic? Just to make sure it's working on all kinds of devices. If you have an iPhone or Android, go to the web page as well. Very basic. And here as a user, you will just be able to create a configuration per device. So what I have done in this slide demo is I have created a new device, called tnc demo. And after I have pressed on create, I can now download the tnc demo configuration. And when I download it, I will actually download the certificate that was created specific for this tnc demo device. Before downloading and installing it, I must be sure that I have the right OpenVPN on my device. So we have put a few links on our webpage that it is relatively easy to just install the right app, or for macOS, Tunnelblik on your laptop, so you can easily incorporate the configuration you will get from us. And the configuration you can download, you can only download it once, just to be sure that if you're downloading this configuration via a rogue hotspot, and somebody is able to, well, rogue hotspot is not really the best example, I think, but if somebody else was able to download it before, you can't download the configuration the second time, just from a security perspective. So on my MacBook, I will get this pop-up after clicking on download, and I can just easily press OK, and then it will be opened in Tunnelblik. Tunnelblik is my VPN client on my MacBook. And what will happen next? I have to give my administrator password on my MacBook. That's not shown here. It asks me if the VPN should be enabled for only me as a user on my MacBook or for all users. Well, I can choose. And afterwards, it will just, well, you see it here, connect tnc demo. It has already inserted the configuration. So now I can just easily use the VPN. And all traffic will be routed via our server. When you have created configuration per device, we also offer the ability to revoke configuration, and you can just revoke per device. I think this is very, well, secure and convenient. So we have launched the former slides as a demo service last year, and then quite some institutes asked us, this is a really nice service, but it's aiming for end users. But we, as an institute, we have our own VPN service running, and we bought it 4 or 5 years ago, or maybe longer, and currently it is not really working very well. For instance, it's not integrating nicely with iOS. It's not working nicely with Android. So, but then we discovered that there are also institutes interested in using this EduVPN service, but for a different use case, just to integrate VPN with their network. So then we thought, okay, we must try, and we haven't done yet. We are currently starting to work on it, that we can integrate EduVPN with your own institute network. So that you as a university can say, okay, we have this new EduVPN VPN service, and if you click here and there, you can just use the VPN service to connect to our own network and have our own university IP. So basically, it works the same. We have the enrollment for the users via our federation service. You will end up in our EduVPN server, and when the university user will start the VPN, via a light path, we will obtain an IP address inside the university network. And as said, this is something we will work on in coming months. And challenging then, or new inside the setup, is then how do we inform the universities about abuse, about logging? How can they identify users, stuff like that? That's still challenging, and we need to discuss that with our institutes. So, what are the obstacles we have seen so far with this setup? Even when you offer VPN and the user is going online via public hotspot, the problem or the challenge is that before the VPN will be started, the user will use the captive portal to do to try to log in, and at that time the user can be attacked, or secrets or passwords can be gathered still. So we still have the challenge, how can we make sure that when a user goes online, that the VPN client somehow can block off all sensitive traffic, but on the other hand, be able to use the captive portal in such a way that he will get internet. That's still something that is challenging. So we need to work on that. But we are on track and moving forward. So what do we have still to do? Well, as said, the integration with the IP space of the institute. We like to have a separate OpenVPN virtual private server per institute, but we like to have the dynamic scaling option. For instance, on regular days there will be around 100 users going online via the VPN, but on some days they might stream a lot of traffic through the VPN, and then our server might not have enough CPU power or so. So what we like to do is that we can somehow dynamic scale. Add additional servers, for instance, maybe add additional CPUs, stuff like that. Because we don't want to be like that an administrator should manage the server whole day, and if there is much traffic, add additional resources. Must be dynamic. The low-level integration I already explained, just to be sure that the user can be fully safe. IPv6 is currently not enabled, and this is due to we are using CentOS 6 in the demo environment. Francois was already working yesterday on CentOS 7, so we can do IPv6, so it should be turned on soon. The choose your endpoint capability, I have not talked about that yet. I think it's also a very interesting case when, for instance, we are now in Porto. If I want to protect the wireless local loop, I shouldn't necessarily go to the Netherlands with my VPN. So it would be interesting if I can choose my endpoint. So if there would be an EduVPN server around here, I could also terminate the VPN here, just to have low latency. In particular, when you're going to Australia, latency is relatively, it's really high. It would be better if you can terminate the server over there. There are, terminate the VPN over there. There are other interesting business cases. You might also be able to when you are in the Netherlands and tunnel the VPN to the United States, get some interesting content in the United States because you have the IP address over there. So this is also an interesting case for users. Planning is that we will decide upon if EduVPN will be an official service for our constituents. That's scheduled for the end of the year. And last thing is we are also thinking about additional use cases we can facilitate via our concept. Something we recently discovered is a VPN service called Zero Tier. A zero-tier is a virtual switch-like VPN. They also mention SDN, software-defined networking. And it's a peer-to-peer-like VPN. And via this VPN solution, it is very easy to connect different machines. And the idea is that if you have VPSs, so virtual servers, and you want to connect many of them, for instance, you have one in Azure, one in Amazon, you could use the zero-tier concept to connect all machines to each other. And it looks very promising. I've seen a demo last week. I thought, okay, this might be a service we might somehow incorporate in the EduVPN approach. But probably with a different use case than we're facilitating right now. Everything we have done is put on GitHub, documentation, we have a wiki. Everything is open source, so it should be easy to deploy it yourself if you're interested. Currently, we have done everything ourselves. And we are looking for collaboration with other NRNs as well. So if anybody is interested in joining our efforts, please let us know. Are there any questions?
If you could introduce yourself, please.
Yes. My name is Kurt Baumann from Switch. I have a question. If you're talking about services, then you have to be aware that your service will exactly deliver or fulfill the SLAs, you know. How do you manage this? How do you monitor this? What is your measurement approach or a guarantee certificate for the users or for the community that will use your service?
Yes. Well, I think with the VPN service, it's within the Netherlands, it's relatively easy. You can just monitor your service from different ISPs, for instance, and check if it's working. Obviously, you can't guarantee it's working on all places of the world. In particular, because some networks, they filter traffic, a good example is, I think, China, setting up VPNs from China to our service. I think it's very tricky, quite hard. So, yeah, you can't obviously not guarantee that it's working in all places. But so far, the users which are using this aren't complaining about that it's not working. So I just think we should do our best, monitor the service, just be sure it's working, and well, in future try to improve it and maybe even add support for DNS tunneling, stuff like that, just to be sure that the user can use it in all places. I think that will be the challenge.
Other questions? I have one for you, Roger. The bootstrapping the trust problem at the very beginning. Yeah, your demo has offering people to sign in with the open IDP. Do you see Surf Connects as an instrumental part on the bootstrap part? How do I trust this VPN in the first place?
Yeah, that's a good question. When I look to how users will react, what they usually will do, well, it was recently in the news that I think it was a VPN technique called Hello or so, some Israeli VPN technique that was very popular. And I think usually the end user just uses a product that is easy to use and not safe and secure. Or, well, if he reads it's safe and secure, the user usually thinks, it should be, or I trust it. So within the Surf Connects thing, I think we have the trust layer involved, and I think when we are able to well, contacts or users that they should use it by default, then they will already install the VPN when they're inside their university, and I hope, well, the trust will be a lot higher than well, the free services that are available on the world.
Okay. And the other observation I had was the create and revocation of the certificate. That's user managed, or is that the operator, like the operator of the EduVPN node?
You mean the certificate that will be generated per device, you mean?
Yes.
It's automatically.
Okay.
So if you guys log in, you can just create a name, and automatically the certificate will be generated for that device.
Okay. Yeah. Well, that's great. If we have any other questions, looking.
Are there any people who have joined my rogue access point? No?
I don't know if they'll admit that.
Too bad.
All right. Just a hand of applause for Roger, please. And Roland. Thanks. Roland's also from SurfNet and be talking about Dane and DNS certificates.
Good morning, everyone. Thank you all for showing up in such big numbers after the wonderful conference dinner yesterday. For those of you who attended my presentation yesterday, you will by now know that I make a point of including a scuba diving picture in every presentation that I do, because I love scuba diving, and this is in Cape Verde, which used to be a Portuguese colony. So if you want to go scuba diving and you speak Portuguese, I recommend going there. My talk is going to be about Dane. Who is familiar with Dane? Not the Danes, Anders. Okay, so it's only a couple of hands. So I'll give you a brief introduction. Dane 101. Now, Dane is a technology that makes use of the DNS to, as it says, authenticate named entities. And the goal is that you can express trust in named services through the DNS. And to achieve that, Dane relies on DNSSEC. Because I hope that most of you are by now familiar with the concept of DNSSEC, which is where you sign your DNS records to express trust in them, and you can leverage that to express trust in additional services. And the currently standardized use case is for expressing trust in X509 certificates or PKI-X certificates. But there are also other use cases for which standardization is currently underway, and that includes expressing trust in PGP keys, SMIME, off-the-record chat fingerprints, and you could argue that existing DNS records like those that allow you to put an SSH fingerprint in DNS are also something like Dane. So why would you use Dane? Well, I also hope that most of you are by now familiar with the fact that not all certificate authorities are as trustworthy or as secure as they should be. Either they are run by governments who may have an incentive to hand out certificates for services that they want to intercept, or we have companies like the famous Dutch DigiNotar, for which we are all very much ashamed, who have their CAs hacked by people from somewhere across the world who then issue falsified certificates for sites like Google.com and Microsoft.com. So how does Dane work? Well, the idea is this. Normally, if you connect to a server that uses TLS, you will set up from your device, you will set up a TLS connection to the server. You will get the serve certificate, and then you will check the validity of the certificate along its chain of trust. Now, with Dane, you can add an additional check, because what you can do is you can request a specific record type called TLSA from the DNS, and the operator of the server can put that record in the DNS, and what it does is it gives you information about the valid certificate for that server. And what this gives you is the opportunity to check the validity of the certificate via two separate paths. So the idea is that you don't just check if the certificate is valid that you get over the TLS connection, but you also check that that is the certificate that is mentioned in the DNS. And this means that for an attacker, if he wants to perform a man-in-the-middle attack or wants to meddle with a certificate, he will now have to control 2 independent paths. And that is very, very hard. So it gives you a very strong trust in certificates. The TLSA record, again, it expresses trust in X509 certificates, and it can do that either directly by including a hash of the certificate or the public key in the certificate in the DNS record, and then you validate the TLSA record and you validate the certificate along the chain of trust. But you can also use a self-signed certificate. Obviously, then you do away with the 2-channel advantage, but at least you can now use a self-signed certificate in more or less a trusted way, which is interesting. You can also do this indirectly, in which case you create a DANE record that has a hash of the signer certificate, so of the CA certificate. And the semantic of that is that you can express that only this certificate authority is allowed to issue certificates for this service. And for instance, if you're Google, that's very interesting because you probably have a relationship with one certificate authority, but not with another. And what happened in the DigiNotar case is that one of the certificates that one of the CAs that your browser trusts by default issued a certificate for Google, but Google had no relationship with that particular CA. And they can now express this through the DNS and say, hey, only this and this certificate authority is allowed to issue certificates for our names. And again, there you can work with a certificate that validates through the traditional PKI chain, but you can also use a self-signed certificate. This TLSA record specifies the port and the protocol on which the service operates. So if you have a web server that does HTTPS, the port will be 443 and the protocol will be TCP in most cases. Very important, and I want you to keep this in mind because I'm going to be coming back to that. If you change your certificate, so if you do a rollover, DANE requires you to have 2 simultaneous records in the DNS at that time. So why did we decide to pilot DANE at SurfNet? Well, SurfNet, who of you uses TCS from their NREN, the Terrain Certificate Service? Okay. So let me advertise TCS. It's really great because you can get certificates really cheap. So we are a TCS reseller for our constituency. And that means that we issue certificates for most of the connected institutions in our constituency. And we are also DNS operator for many of them. And that means since we both have control over what certificates are issued, and we know which certificates are issued, and we also help our institutions manage their DNS, we thought we might be able to automate DANE for our connected institutions. And that would be great because it might reduce the complexity, it might reduce the risk of breakdowns. So our goals with the pilots was that we wanted to get some hands-on experience and also to get some feedback because if you work with certificates, you're probably going to have a process because these certificates need to be renewed every once in a while, so you need to manage those. And we wanted to know if what we came up with matched with the processes that we had within the connected institutions. And if this pilot was going to be successful, we wanted to make it a best practice that we could disseminate through organizations like the IETF or ICANN. So we started out with a POC, and just to give you an idea, this is a screenshot of our managed DNS environment. You probably can't read all of this, but what you can see here is a DNS zone, and this is the DNS zone for digi-n0tar.nl. I couldn't resist the pun. Here there is a TLSA record for a web server. So what we did is we made it possible to include TLSA records in DNS zones simply so that we could test if it would work with browsers or other software. First I'm going to take you back to the processes that we have at our connected institutions. So usually we see three roles within the connected institutions. On the right-hand side of the figure, you see the DNS manager. And that is the person who is responsible for registering domain names, managing DNS zones for the institution. In the middle, there's a system administrator, and they are responsible for managing a server that uses TLS. And on the left-hand side, we have the local registration authority, and they are the trusted entry point into the organization who requests new certificates for the institution on behalf of the system administrators. And these three roles in a bigger institution will typically be fulfilled by different people, and they will have separate operational responsibilities. So if we want to add Dane to this mix, we do not want to break this role separation, because that is going to be inconvenient for our connected institutions, and they probably have good reasons why they have this role separation. So how did we do this? Hopefully you can see that I've added some red lines to this figure. So what we do is the system administrator who manages the server which has a TLS service on it needs to request a new certificate. If they do Dane, that also means that there should be a new TLSA record for that particular service. But rather than forcing them to have to send an email to the DNS manager to please fix this and then have to wait and maybe the DNS manager forgets to do it and it breaks, the DNS manager gets the opportunity to delegate management of Dane to the system administrator. So when the system administrator installs a new certificate, they can go into the DNS management portal and say, hey, I'm using a new certificate now, can you update the Dane records? Equally, what we do not want is that the certificate starts being used before the accompanying TLSA record has been created in DNS. And I'll tell you a little bit later why that would be an issue. But during a rollover, that might break things. And so what the portals will do is they will communicate with each other, and the certificate will only be released if the appropriate Dane record has been created. So what does that look like? So DNS managers now get extra options, which is the little certificate icon that I've magnified on the right, and if they click on that, they enable Dane management for that host. And what that means is that somebody who is a system administrator then sees the domains for which he can manage certificates, and he can then upload a new certificate if there was never a Dane record for this service, or he can perform a rollover by notifying the system of the new certificate. Once Dane is enabled, the system administrator can see some status information, and the green tick mark shows you that everything is working fine. There's a Dane record, and it validates along the chain of trust, both in DNS as well as through the PKI chain of trust. When they do a rollover, they supply the new certificate, and then they have to wait for it to become active before they start using the new certificate. I'm going to skip over these. So what were our pilot results? So we implemented this, and it may look kind of complicated, but actually from the system administrator point of view, the changes are very small, and the same is true for the DNS manager and the people that do the certificate requests. So the implementation worked as we envisaged. The Dane and TLSA records are published on time, certificate renewal worked as expected, so it was a perfect pilot success. But we were not happy with our results, and I'll tell you why. Problem number one is the rollover model. If you have a traditional X509 certificate, that has a limited validity, right? It's valid for 1, 2, 3, sometimes 5 years. And after that period, you have to get a new certificate from your certificate authority and replace the existing ones. That is already hard for most people, right? Who here has never had their bank forget to roll their certificate? I see no hands going up, so you've all had really badly doing banks. My bank has forgotten twice, right? So you go e-banking and you get a pop-up, this certificate is untrusted. That's not what you want, right? So that's hard enough for most people to replace their certificate in time. But if your certificate is nearly expired and you're not using Dane, then at least you can rush the certificate request, get a new one, install it, and be done with it. But if we add Dane to that mix, we add complexity. Because Dane uses DNS. DNS records are cached all over the place. So you have to take that into account when you're changing your TLSA records, because people might be seeing your old record for a while, but not the new one. Right? So if you're replacing your certificate, you will need to co-publish 2 TLSA records. And the new certificate can only be started to be used after the DNS caches have all forgotten about your old certificate and all know about the new one. And that may take, depending on how you configure your DNS, several hours or even several days. And that is a risk. So you would argue that you can automate this, right? Which is exactly what we try to do, because this is a big risk. So we try to automate this. But then still, in case of an emergency rollover, right, people forgot to replace their certificate in time, well, shit. That's a problem. What we did is, if a certificate expires, we retract the TLSA record, so that if there is an emergency rollover necessary, the TLSA record is probably gone, so you can safely replace the certificate immediately. But it's still an issue. And only if you have a really mature ICT process, maybe if you are fully ITIL compliant and you have everything down on paper, can you manage this correctly? Problem number 2 is port numbers. As I hope you are aware, certificates do not have a port number in them. They have a host name in them, but there's nothing about the port on which the service runs. And services that use TLS can run on any port, right? If you have a web server that does HTTPS, it will be on 443. But if you are doing a mail, then you will be using TLS on port 25 or on other ports. And because certificates and certificate signing requests have no information about the port number on which the service runs, this will need to be entered manually for the system to be able to generate the appropriate TLSA record. So we thought maybe we can do port scans to detect where people are using certificates, but that might be ethically shaky. And also, the servers that use the services that use TLS may not be reachable, right? They might be an internal service only. And also, protocols like, for instance, SMTP that use start TLS are problematic, because then we have to initiate a connection, do start TLS, and then what are we doing? I mean, we're sort of pretending to be a user, trying to retrieve a certificate, so that's not really desirable. And the biggest problem number 3, is that the use case that's being advocated for Dane, which is to use it to protect your website through an additional channel, has become shaky over the past year and a half. Because the only support that there is for Dane at the moment in browsers is through plugins. And actually, in the past, I think it was 2 or 3 months ago, Google announced in a blog post that they will not support Dane in Chrome. And they explained why, and I'll show you on the next slide. But this means that Dane is now effectively being killed for the web. Because if the browser vendors are not going to support it, why go through all this trouble to have that certificate information in the DNS? So I'll explain to you why the browser vendors are reluctant to implement Dane. This is do you remember this beautiful picture of how it should work with the 2 separate channels? Yeah, this is what it looks like in reality. And I'm oversimplifying things because it's probably worse. What you typically have is that you have a local DNS resolver. You might be running something on your end user device that will be talking through a really cheap and dirty DSL modems that tries to mangle DNS in all sorts of interesting ways. That talks to your ISP DNS resolver, and if you're really lucky, they all let through this Dane information, but it's highly unlikely. Then there's a firewall between your ISP DNS resolver and the internet, which throws away fragmented responses, so half the DNSSEC responses get discarded. Oh, and you're in a hotel, right? You're all in hotels. They have these annoying SSL proxies, and so you get mixed certificate information, so it's very likely that the validation will fail because of that. And the matching has to be done on your laptop. Seriously, people, that's not going to fly. And this was the argument that Google used, and I tend to agree with them. This is an issue. So, sad face. I haven't got a slide with a sad face, so I'll try to look sad. Can we improve things here? So we looked at the rollover issues that we had. I'm not going to go through this in detail, but we could do something with port numbers in certificates, but that requires standardization, takes forever to do. It's not an alley you want to go down. We could extend the TLS protocol with certificate selection, so rollovers would be a bit simpler. Again, standardization is a no-go, will take years to do. We thought of building one portal to rule them all. So people could make fewer mistakes rolling their certificates, but that would cost a lot of money. And given that the use case for the web is mostly dead, we thought that would not be a good investment. So is Dane useless? I would argue it's not. There is a very strong use case for Dane, and that is email. Because in email, it's servers talking to servers. Right? So you won't have this annoying SSL proxy, unless you run your mail server in your hotel room. Who doesn't? You will have a lot of control over the DNS resolvers that are there. You will have control over all the connections going in and out of that data center where you're running your server. So that's a completely different arena. Now, mail transfer agents try to use opportunistic encryption. So they will try to initiate a TLS session by sending start TLS to the server on the other end. And then if that succeeds, then they will encrypt the connection so that people cannot intercept your email as it is being transferred across the internet from MTA to MTA. The problem with this is that these are mostly self-signed certificates that people use for this. So it is really opportunistic, trust on first use. And it's easy to man in the middle and not to discriminate. I'm not just naming the NSA, but also the Deuxième Bureau, the Bundesnachrichtendienst, and pick your intelligence agency of choice. But Dane can come to the rescue here, because now if you operate a mail server and you have a self-signed certificate, you can put information about that certificate in the DNS. And the other MTA who's trying to talk to you can request this information and check that they're talking to you and not somebody in the middle who also has another self-signed certificate. Because you can't tell the two apart if you're just doing TLS. And the folks that make MTAs have started to realize this. So if you're using a recent version of Postfix, which is quite a popular MTA, they support this. The most recent nightly builds of Exim also support this. So if you want to do something with Dane, look at email. So I'm coming to my conclusions. Dane is a bit of a mixed bag. And it says warning, opinion. I think the IETF should have paid better attention to the operational realities. Managing certificates is hard. If you add TLSA to this, if you add Dane to this, you're making something that's already hard almost impossible. And I had discussions with the folks that were in the Dane working group, and they're like the Unix beards in the Dilbert cartoon, where they say, hey, system administrators should be able to do this, right? Well, as it turns out, system administrators are really people that have such a high workload that if you add this to it, you're making their lives miserable. So for the web use case, that's really a shame. It's a missed opportunity. There is one exception to this, right? If you are a full-service hoster, aka a cloud hosting provider, you can completely automate this for people, right? If you run their web server, you do their certificates, you do their DNS, you can automate that. So it's great. You could do it for them. But that's a missed opportunity. Because, for instance, what we have seen with DNS security is that TLD registries, so the people that run top-level domains like .com, .net, .org, they've been giving financial incentives to deploy DNSSEC. And what you then see happening is that the big hosters that have hundreds of thousands or millions of domains will turn it on. Because if you get 2 or 3 cents of the price of a domain name as a big hoster. That matters, right? But the organizations where it really matters, like your bank or your government, who only have very few domain names registered, they're not incentivized by that. So in the Netherlands, for instance, where we have about 50% of all the domain names signed with DNSSEC, which is a really great result, and the likelihood that the Asian restaurant on your street corner has a DNSSEC signed domain name is about 90%. The likelihood that your bank is using DNSSEC is about 5%, because there's only one bank in the Netherlands that does it. And the same could be true for Dane, and that's a shame. So Dane is complex, right? And the cost of automating it does not outweigh the benefits. And it doesn't reduce the risks. And that's simply because of the mismatch between how you work with certificates now and how you would have to work with certificates if you use Dane. But we do want to support Dane, and the email use case is a really good one. So we've enabled the TLSA record type that we introduced in the proof of concept, and that is available for connected institutions to use. And we're thinking about including some sort of wizard so that they don't have to make the record themselves. They can simply drop the certificate and it will generate the appropriate record for them. And we're going to have to look into the benefits for email, right? Because that's really an interesting use case, and you see that starting to get deployed at a larger scale. Apparently it's very popular in Germany, for instance, where they are trying to have German mail, which is like completely protected, cannot be intercepted, etc. And with that, I end my presentation. Does anybody have questions? Yep.
Just wait for the mic, it'll be right to you. And please introduce yourself.
Hi, I'm Thijs Kinkhorst from Surfnet. Maybe you already knew that. So you have the rollover problem. You have the same problem with email, right? So if
Yes, that's true. No, you will still have the rollover problem with email. So you will still have to manage that correctly. But the benefits that you get with email are so much more than the benefits that you get in the web arena, that I would argue that there the benefits outweigh the risks. So there I would say it's worthwhile to take the risk.
Because currently email servers will use opportunistic TLS. So if something is wrong, they will still do it. Something better than nothing. But if you introduce Dane, you would suggest that you do not do opportunistic?
Either you can do away with opportunistic encryption. If you are paranoid about your mail users, I would say don't do opportunistic encryption if you have an indication that something is wrong. So if there's a mismatch between the certificate and what Dane tells you, I would argue don't transfer the email. If you don't have a Dane record, then you're in the same situation you were before, so simply do what you did before. Yeah. Any other questions?
Going. Well, thank you very much. Dane has been around for a number of years, and I presented on it with the eduroam side of things, and it's promising to see some emergence of it in the examples that you're talking about, but it still looks like it has a way to go, and I hope people look at the stream and some of the comments you make. I too am disappointed that the browsers are not picking up the gauntlet, but for the reasons that you stated. So thank you very much once again. Just a round of applause, please.
Thank you.
And next up, Domenico. Absolutely. Talking about perf sonar.
Good morning, everyone. It's really lovely to see you here. My name is Domenico Vicinanza. I work for Giants and Anglia Ruskin University in Cambridge. And what I'm going to do today is a brief summary of what happened in the past year about Persona. So, as you know, Persona is a community-developed, community-maintained software suite that provides a number of tools that can be used to pinpoint and resolve network issues, but also to set network performance expectations in a way that we can better manage our network, we can plan better our network deployment, and we can make informed decisions about the future of our systems. And finally, also helps creating a framework to visualize and analyze data and archive them, and as we are going to see today, also to offer researchers the possibility to download this data and do the research on it. So how does Persona work? Well, in a really, really simple way. Imagine you have a couple of hosts and you want to do measurements between the two. What we need to do is just installing two Persona servers as close as possible to the network elements. So ideally, they should be just plugged in a router port, making sure they can talk to each other, they can see each other. And we just need to install the Persona software. And the result is we have a set of metrics available on the path, and we have a web interface to visualize and to get access to the data. So as you remember, roughly exactly 1 year ago at TNC 2014 in Dublin, we presented the first converged persona, so the first effort in creating one single persona all over the world. And we did the demo with 4 measurement points, 2 in the US and 2 in Europe, and we were able to actually do measurements and see measurements between those 4 endpoints. So what happened since then? Well, in October 2014, so after a few months, we presented the first prototype. The first public release went out, and that was version 3.4. So with this version, on-demand measurements could be enabled between any couple of hosts in the Persona group, in the Persona family. And this was the first step towards a real convergence between the two tools. This is just a graph showing how Persona grew in the last 3 years, and you can see we moved from roughly 500, 600 nodes in 2012 to more than double in roughly 3-year time. So it's a really big success, and that's just a glimpse of what happened in the past 6-7 months. So between October and now. So we are now over 1,400 nodes all over the world. So it's a really, really big community. It's a big thing now, and it's the widest and largest network monitoring tool for research and education, which is entirely community-based and open to everybody to contribute. So next release is coming next month as release candidate 1 in preparation for the next production release that will be September. So what's coming next? So what's in it? There are four main themes in this release. We have the support for central host management, so CF Engine, Puppet. We have support for low-cost nodes, support for Debian virtual machines and additional use cases, and the new graphic user interface. I'll be touching on all these points later on in my presentation. So first of all, the big news. We had a lot of requests about Debian. So that many people are using Debian or using Ubuntu in the community. So we thought it was really useful to have a Persona release based on Debian. So the tools has been ported to Debian 7. We have 4 architectures supported. The standard i386 and AMD64, but also ARM processors for mini boxes or mini servers that can run on probes, for example. We have 2 main bundles, a bundle containing the tools, so iPerf O1 PWCTL, and the bundle containing the controllers, so called endpoints, which includes the registration in the lookup service, the testing, regular testing scheduler, the OPPD. OPPD is the on-demand component for Persona. If you are interested in that, have a look at the documentation on docs.persona.net, and there is a brand new part called Install Debian with all the instructions about Debian. We have extended our use cases. Before Persona was targeting users that wanted to get something really quickly up and running. So our decision was to have everything bundled in one CD. Operating system based on CentOS 6, plus all the tools you need. So the idea was I just put my CD-ROM in my computer, or I download the image, and that just worked. But this is not compatible with most system administrators are actually trying to do, which is managing a farm of systems under certain conditions and patching the software, patching the operating system, and applying their policies. So what we thought it could be useful is disconnecting the operating system and and just the tool. So we started creating RPMs and web packages just with the tool, so that it is easier to manage a persona infrastructure in those conditions. But also having persona hosts that can self-configure if needed, using DHCP and using standard parameters, so that a persona node can be deployed really quickly if we need. And hosts that have just the NDT tool in it. This is just a brief list of all the persona components. I'm not going through that in detail. Just to let you know that we have the usual measurement tools and measurement archive. We also have a test mesh management tool. We have a data analysis tool, plotting data from the archive, comparing data. We have a dashboard, and we have a lookup service. We have a new persona website. It's persona.net, and it has been extended during the past few months with quite a lot of information about what is persona, how does it work, who is using persona, how to get on board, how to solve common issues, and also how to navigate the interface, how to use the interface, how to retrieve the data, and so on. The main news from a visual perspective is probably the new user interface. Our previous UI looked a little bit old after a while, so this is how the new host management interface now looks like. We have here the list of services showing the status, the version, the port is running. We have here a part dedicated to the host status with CPU usage, with even including the MTU on the network ports. We have test results, how many active tests are scheduled, what is the result. So we hope it's a little bit more user-friendly. But of course, feel free to give us feedback on the persona user list. We have also an updated web user interface to get result and visualize the result. And probably the main news is that we are doing quite a lot of work in integrating the user interface with Educate, so that everybody can actually use federated login to access the data and to run on-demand measurements. This is how the user interface currently looks like. There is the possibility of accessing measurements that has been done in the past, but also to schedule measurements, to do measurements on demand. And this is probably one of the most probably useful things that are available in from the interface. We can do throughput measurements, we can do latency measurements, and in the past months, what we did was integrating the user interface with the lookup service. Lookup service is kind of yellow pages that tells you where the available measurement points are. And this is the result of the integration, and it works with a dynamic filter, so you can actually start typing. Let's say RNet, you can start typing. You can type NASA if you want to know you want to do a measurement, for example, with a NASA measurement server, which has been deployed somewhere. Or you can put Surfernet, you can put Giant, you can put whatever your domain of interest is, and you can actually see what's there. But most importantly, this tool can also do a quick check, so send a query message to the host and actually detect what are the measurement points that are available at the moment. So not only giving you the list, but also immediately checking whether that measurement point is unable to respond, is there, is disconnected, or is alive and is ready to take your measurement. So you're actually saving time. So how does the measurements look like? So this is a standard TCP measurements between two hosts. So this is London, New York. And one of the things we can do with this interface, well, in addition to get the result in a graphic way, or in a table, there are a few parameters we can actually tune or we can tweak from the interface itself. We can change the protocol from TCP UDP, we can change IPv4 or IPv6, we can change the window size. And we know how this is important, doing measurements on, in particular on long, fat networks, how sometimes it's really crucial to have the possibility of tweaking the TCP size, window size, to make sure that we are actually measuring the right thing in the right way. And this is just a detail. Quickly on the other things we were working on in this release, I mentioned before we improved the support for central host management. This again was something that has been requested many times. The idea is to support system administrators and IT teams that need to deploy Persona or on a large basis. So including Persona into their existing CF Engine, Puppet, Chef host management systems. And the idea is making it easier to manage many Persona hosts in the same institution in a coherent way, in the same way, so that if I need to patch, if I need to update something, I can do that in a really smooth, predictable, and reliable way. And we have new RPM bundles just to support that specific use case. Another thing quite interesting is the possibility of using the auto configuration for a node. So here the goal was to have a Persona node really easy to deploy. When we install measurement software, measurement tools, there is always some tweaking to do, some installation, some configuration to do. And of course, the more user-friendly or the more immediate or the less we have to manually type or to manually enter, the better it is. Ideally, we like to have something like a speed test. We just connect to, I just want to test my network against that specific beacon, that point, and that's it. I don't want to stay there and specify if I want to use a certain version of TCP or UDP, and if I don't really need to. So in this case, the auto configuration, we still register the node in the lookup service in a special place, in a special way, so you can actually discover the service. You can actually know in real time what are the other hosts we can use. The nodes knows where to send the test results, so where to store the results, where are the archives, and it uses DHCP to get the IP address. So in this case. Finally, Persona for network researchers. Persona has been a really important tool for many universities, for many research groups, because it's a comprehensive tool to gather information, to gather measurements, numbers, data, and many organizations in the research and education are running now Persona nodes for many years. So they have quite a lot of data there that can be really useful for researchers, for people doing data analysis, network analysis. And so we thought to create a mechanism to make sure that this data is accessible to researchers in an easy way. So we are using an Esmond PS get bulk command now, so is now available, and basically the output is either a CSV or is a JSON, depending on what we prefer, and data can be then used. Can be downloaded and analyzed offline by network researchers. Finally, Persona hardware. So a few words about what we need to actually run Persona in terms of hardware. In the past, people were normally thinking about network test servers as something quite expensive and something quite demanding. So a big investment for universities, for research centers, for end-brands. The good news is that now any reasonably new one-unit server will actually do. The important thing is that we have a good network interface, and possibly we just dedicate that server to measurements, because we want the CPU free do timestamping and processing the packets, and we actually want to measure the performances of the network and not of the PC. Again, good news. Now, any server below the servers below $500, or roughly around 500 euros, there is a list of servers that are suitable, and there is a discussion in the Persona user list. So please feel free to have a look there. Feel free to contact us if you need any suggestion, any recommendations about what server to buy, what's compatible. Probably the most expensive thing will be the 10 gigabit network card, so which is in addition to the $500 or euros. That will be probably the most expensive part. But another good news is that even now the really cheap 1 gigabit mini computers are now available, and they're now suitable for Persona. We have special release for them. Unfortunately, the ARM ones are not yet fast enough to sustain a 1 gigabit flow. But if you are just happy to measure jitter, to measure one-way delay, you can use even a small ARM device, even Raspberry Pi, and work on it. We don't recommend to use virtual machines because we really recommend to have the network interface dedicated 100% on your measurement tool. And finally, Persona is a community effort. So it's based on the community working together, sharing information, sharing data, sharing experiences. And we have an active and growing community. We have 1,400 nodes all over the world, and you see, it's growing quite fast. And this is because we have a community behind it. So it's not just a few developers having the task and the responsibility of doing everything. And the great thing about the Persona community is that every time there is somebody asking help on the Persona user list, I can see that after a few minutes there is somebody else providing a reply, providing a response, supporting and sharing information. And it's brilliant. I think that there's no commercial tool that can actually provide such a quick way to get problems solved. And this is thanks to the fact that we are a community happy to share and happy to help each other. So this is my last slide. There are here some useful links, and have a look at the website, have a look at the documentation. There are suggestions about on fastdata.es.net. There are some suggestions about how to tune your host to make sure that it is optimized to do measurements. And if you like to contribute, if you like to have a look at the actual project code, there is a GitHub repository there for you to have a look at. And that's it. Thank you very, very much for your time, your attention.
Well, thank you very much. Do we have any questions? Yes. Just wait for the mic and please introduce yourself.
Good morning. I am Xavier Janin from Renater. I have a question regarding if I have some users who would like to use the personas, but one of the question is I will have 1, 2, or 6, I would say, endpoints, and I would like to use it only for making tests between these endpoints. And I would like to be sure to be protected that the 1,400 other guys as kind as theirs, but don't use it, is not able to make any test with my own endpoint. So how do you manage this kind of group, I would say closed groups that would like to benefit from Persona but not have security constraint?
Of course, security is of course really important, and finding a balance between being open and being safe, of course, is always tricky, as we've seen also in the previous presentation. So one of the mechanisms Persona uses is based on the BWCTL community files. So basically, what we can do, you can narrow down quite precisely what are the hosts available to do what? You can say this IP address, and this subnet, for example, the entire, let's say, /27 subnet, are able to do TCP measurements, but not UDP measurements at all. And TCP measurements only up to 2 minutes. These two hosts, these two guys, are two people I trust because we have some mutual agreements, because we do tests with each other, we know each other very well. I know them and I trust them, so I probably give them, and just to them, the possibility to do longer tests and even to do some UDP tests up to a certain threshold. So you can narrow down very, very well who is able to do what, and you can sustain multiple communities. So there is no limit about how many of these communities you have. So you can have a public profile, anybody can do, let's say, 30 seconds test, and that's it, TCP. You can create some, let's say, special profile, some PERT profile for, let's say, engineers that have some special training, and using that, you can be pretty flexible, but also pretty open when you need to be open.
All right. Well, thank you very much.
Thank you.
And I think this is the last speaker for this session. And it's been a privilege to be a chair for tnc15. And I'd like to say thanks for you guys in the audience, also to select this session for your Thursday morning. And with that, let's have a round of applause for our speakers. Thank you very much. That's the end of the session.